Welcome back to the channel. Today we are looking at database migration testing for QA Ops. We are focusing on how safely apply database changes when deploying new application versions. When your team deploys, the database schema can change. You add columns, split tables, or create new indexes. But if the new application is broken, you have to revert. The critical architectural question is, can you safely revert the database without destroying data or crashing other microservices? In a mature pipeline, database migrations are version-controlled text files. Standard tools use an up script to apply the change and a down script to undo it. These are applied in CI pipelines on every pull request. But here is the massive operational risk. Most engineering teams only test the up script. If an up migration drops a column, running the down script during an emergency production rollback will recreate that column, but it will be empty. This risk gets exponentially harder if you have a shared database architecture, where two different microservices connect to the exact same database. If Service A deploys a migration that renames or drops a column, Service B will crash immediately because its code is still looking for the old schema. To fix this, architects use the expand and contract pattern. You never mutate or delete a column in one step. First, you expand the database by adding the new column. Then you update both services to use new column. Finally, in a separate release later, you contract the database by dropping the old column. Here is how you can use it in CI/CD pipeline today. Step 1. On every pull request, spin up an ephemeral database, seed it with real data, and start both Service A and Service B. Run the migration up script. Then run your automated API tests against both services. If Service B throws a database error, the migration is destructive, and the CI pipeline must block the merge instantly. Step 2. Build an automated rollback test. In that same pipeline, run the migration down script. Use a validation script to compare the current database state against the original. If a single row of historical data was wiped out during the rollback, fail the build. You must prove the database can safely revert without data loss before the code ever reaches next quality gate. Step 3. Build a forward compatibility test. When you deploy to production, the database usually updates before the application servers finish restarting. Simulate this gap. Apply the new database migration, but run the old versions of the application code against it. App must survive the new database schema to guarantee a zero downtime release. Building these ephemeral database pipelines manually is a massive engineering lift. Fortunately, modern tooling can automate this. First is Atlas. Think of it as Terraform for your database. It dry runs the migration and uses static analysis to block destructive changes. Second is pgroll for Postgres. It automates the expand and contract pattern, allowing your old and new microservice to run with zero downtime. Third is Bytebase. It scans every pull request for over 100 anti-patterns. To summarize, mature QA Ops architecture means treating database schema changes with the exact same rigor as application code. By enforcing the expand and contract pattern, systematically verifying safe rollbacks, and adopting declarative tooling, you eliminate data loss and guarantee true zero downtime deployments. If this architectural guide helped you build better systems, please subscribe to the channel for more QA Ops technical deep dives. Keep building strong pipelines, and goodbye.